That's very good. So have your videos on, that is something which we need to do for the speaker's purpose. You have to understand Raj Vedam ji is in Houston now. Today it is night 10:30 there. And he has come only for you children. He's made it available. And he's an outstanding speaker and he has done so much of research. It's an opportunity. It's a basic thing we can do is to have your videos on and interact with him. Note down if you have any questions or anything, and you can talk to him. It's an opportunity for all of you. We have requested him also to keep some time for question answers. So you ask questions. And I think this is the first chapter in the class 11 book, right? Am I right? Astronomy is the first chapter. So
yes, this is a first module, ma'am. First module.
And you have your this is one which is going to be also tested on the summative paper. So you will get a lot of inputs from him. So it's very, very useful for you.
Shall we start, Amma?
Just 1 minute. Some of them are joining because the half-yearly exams are there for a school. So I requested them only these children can start the exam later. So they are joining now. And Amma also said that some of them are having classes now.
9 o'clock.
9 o'clock they will come. Okay, Meena, we can start the session.
Yeah. So Hari Om and welcome to this beautiful session on a beautiful Saturday on astronomy. And to begin, we will play the prayer rendered by Shruti Mohanty from Vidya Bharati Chinmaya Vidyalaya.
Hari Om. Guru Matra Pita, Guru Bandhu Sakha, Tere charanon mein Swami kare koti pranam. Guru Matra Pita, Guru Bandhu Sakha, Guru Matra Pita, Guru Bandhu Sakha, Tere
Thank you. Thank you for that beautiful recording and rendering. I now request our director, Shanti Amma, to introduce Dr. Raj Vedam. Over to you, Amma.
Thank you. Am I audible, Meena?
Yes, Amma.
Thank you, Meena. Welcome to all the children who have come again today for this session. Welcome all of you, and I'm sure you are getting a lot of wonderful, inspiring talks by people. And we have one such person here, Dr. Raj Vedam ji. Welcome, Raj Vedam ji. It's a pleasure to have you amidst us. And I really, really appreciate your time and efforts in joining at this hour of the day there. Raj Vedam ji is in Houston now and he's late in the evening, but he is joining only for you children. Please take the best opportunity out of it. Raj Vedam ji, for the information of you, we have some of the schools taking up this subject in class 11 as an optional subject, knowledge, traditions and practices of India. And it's such a beautiful subject it is, and we have taken, Chinmaya Mission has taken a commitment to promote the subject and get more and more of them involved. Last year, we had about 8 sessions where we prepared the class 12 students. Outstanding informations were shared with the children, and they all were completely inspired, and they scored very well also, because we are going beyond textbooks to give them, enriching them with the actual information. I'm sure that is the purpose of the whole subject, is to enrich them with the right facts about the country. And this year, I had a lot of requests from people. Other than Chinmaya Vidyalayas, also there are schools, Amrita Vidyalayas and Shri Ravi Shankar Vidyalayas, they too join us. Some of them are in classroom setup, but we have a good number of children here. And this year, a few schools are going to start. So the teachers are joining from March, April, they are going to introduce. That's about the audience here. We have a very inspiring group of children here. They will ask a lot of questions. I request you to keep at least 10-15 minutes towards the end for them to ask questions. And with that, I can see Arundhati Amma here. Arundhati Amma, thank you so much for joining us. And I'm grateful to you for, referring Vedam ji and also connecting with Vedam ji with me, that we could get him. I mean, I think it's a wonderful opportunity. We grabbed him. And children were excited, sir. I should tell you this. When I said Raj Vedam ji will be speaking last week, when I announced, they said we're really, really waiting for it. Some of the schools mentioned that to me. They frequently watch your videos. Your videos are very, very popular among some of the students. And those who are not watching, I request you please go through. His talks are absolutely superb. Talks are there. I'm sure you have to take this opportunity. And it's my privilege to extend a welcome and also to introduce Dr. Raj Vedam ji. He holds a doctorate in electrical engineering with many years of multidisciplinary experience, and he has developed a strong research interest in the history of sciences, mathematics, and technology. His research shows, though not acknowledged, but significant contributions of ancient Indians' contributions to sciences and mathematics, impacting the several civilizations over different periods of time. While Western texts on the subject enforce a parochial narrative sourcing all sciences and maths from ancient Greece or Rome or Egypt, Raj Vedam ji presents contrary facts and evidence to show their indebtedness to the Indian civilization. He has presented his findings in over 200 public talks, several teacher training workshops, several research publications, and he currently is offering courses in the Hindu University. Unassuming person that we are able to reach to him and request him just for the benefit of all of you children. I think it's a wonderful opportunity. Let us put our hands together and welcome Shri Raj Vedam ji, and to take it over to you. And I have to also share this with you. He has gone through the syllabus. He has gone through the lesson which was shared with him. So here is an opportunity to talk to him directly and get involved. Bombard him with questions. And I don't think there's any better person than Dr. Raj Vedam, where you can post your questions. Over to Raj Vedam ji. It's our privilege, Raj Vedam ji, to have you amidst us. Thank you so much for joining us. Over to you.
Hari Om, and it's a real pleasure to come. Thank you for inviting me to speak to all these wonderful students from across the country. It's a privilege. So students, I'm really happy to be here. So let me share my screen. Give me just a minute to get organized here. And tell me if you can see my screen.
Yes.
Yes, Jay, we can see.
And before we start, one last question. Shantiji, how long is this talk? How much time do we have?
We do have 2 hours time, but
Wonderful.
according to your convenience, you can, if you want, you can wind up little early because it's too late for you. I leave it to you.
That is completely okay. Not a problem at all. It's my pleasure to talk for as long as students are interested in hearing. So I will try to cover as much as I can in this talk. So with that, let's get started. So Om Shri Guru Bhyo Namaha. We come from a civilization that always pays respects to our gurus, our teachers, and so many present-day teachers who are teaching us with their research and so on. So our grateful pranams to our gurus and teachers. So students, I'm going to go far beyond probably what your textbook asks you to know. And hopefully it won't be too intimidating, should be easy to know. So first of all, when we talk about Indian astronomy and say that it has got a glorious past and so on, people ask, where is the evidence? We had to be an evidence-based civilization, right? So we had to show evidence. Yes, practice of Indian astronomy was there in the past, in archaeology, in texts, and so on. And we had to try to show these things. Even before we start, we should know that in India, astronomy was always in the context of trying to mark the passage of time. So the passage of time had to be regular, right? You had to understand, how can I mark the passage of time? And so people observed that the moon is undergoing some phases, it's going through some ecliptic in very predictable manners, including the sun is going through some predictable movements, and the planets too. So they tried to study the skies in order to keep time along with celestial calendars. Today, you have a calendar on your phones, cell phones, or at home, and things like that. But here in the past, we kept time by looking at the skies, the celestial calendar. That's what we're going to learn over here. What about the archaeological evidence? There's a whole lot of them. I've just taken one or two things over here. For example, in Kashmir, very ancient. We can't even say how old this rock engraving is that is showing this stick figure holding the sun and the moon. Or in Karnataka, on a burial, we see the stars and the sun. In Kashmir, once again, we see the 4 cardinal points of astronomy, meaning the 2 equinoxes, the winter solstice, summer solstice positions. And in one more in Kashmir, showing a supernova, perhaps 2 suns in the sky, and so on. So very, very interesting to see some of these things. Then in Harappa itself, you got many seals. You already know about the Indus Valley civilization. And this is a very famous seal called Pashupati seal. And this is one more a seal with standing figurines. There are researchers who have tried to show that this has got astronomical significance. For example, Professor Abhayankar, he says that this shows these these figurines, these animal figurines over here are showing the equinox and solstice positions 5,000 years ago. And this one over here is showing a very important epoch in India. This is called a Kali Yuga, which dates back to 3102 BCE, with several planets aligned in a certain nakshatra. So he tried to interpret this in terms of that. And going on, all over India, we have got what is referred to as megalithic structures. Some of you in Tamil Nadu might have seen in places like Dharmapuri, Hosur, and other such places. We have got stone circles, we have got labyrinths, we have got huge menhirs, all these kind of things. In this paper, these researchers in Andhra Pradesh, they tried to see these megalithic stone structures, how it is aligned. And their studies, they tried to show that it is aligned pointing to where the equinox or solstices would be pointing to. So it was a way of keeping a calendar for them to say that when the sun reaches this point, then a year has passed, and so on. So very, very interesting to see, even from very ancient times, Indians have tried to mark the passage of time in terms of the year, equinox, solstice, and so on, using these rocks. Then we also know that very ancient knowledge was encoded through stories. Today, there are people who listen to Indian stories or the past and say, oh my goodness, this is all such nonsense. I don't even understand what these stories are. How can all these things be true? But people don't realize that our ancestors were not fools. They were as intelligent as you and me, and perhaps much more too. The possession of a cell phone or a computer does not make us more intelligent than the past. One should remember that. Their IQ was as much as ours, or perhaps even greater. So they did not make all these stories because they thought it was true, but they were encoding knowledge into it. They were encoding some kind of knowledge. And we see that again and again. For example, you might have observed in pictures of this form, or if you have a camera at home, DSLR camera at home, put it on a tripod after sunset and point it to the northern skies and keep the shutter open for half an hour or 1 hour, and you're going to see these kind of star trails. These star trails are basically the rotation of the Earth. As the Earth rotates, we observe that this star in the center is stationary, whereas these go in the small radius circle, and these are larger and larger radiuses. You're seeing other stars go around. So these are the familiar star trails, and this is the pole star. This is encoding the rotation of the Earth. And we have seen that, for example, in several of our Purana stories, in Bhagavad Purana, for example, there's a story of Dhruva. You might have heard of it as a child, right? Or read some comics that talk about it. So Dhruva left his home at a very young age to do tapasya. And one fine day, Bhagavan comes to him and asks him, what do you want? He wants nothing because he's in a state of bliss. But Bhagavan says, after his time, he'll make him into a motionless star in the sky, across whom even the Saptarishi will go in pradakshina around you. That is what the story says. Later on, we're going to see this a little more. But what we see is encoding the fact that the North Star or the pole star is motionless in the sky. It stays in its position. Even as the Earth is rotating, it stays in its position. It does not change. But all the other stars appear to go around Dhruva. So that is encoded in the story of Dhruva. Then we see, for example, there are other stories. You might have seen the story of a monster or a Rakshasa called Vrika. So this person, he did tapasya and he got a bone from Rudra that if he places his hand on anybody's head, that person must die. So Rudra reluctantly gives him that bone. But the minute he gives him that bone, this Rakshasa Ashura starts chasing Rudra because he wants to see if Rudra will die. He puts his hand on his head. Then in the course of that, there is a divine maiden who comes over there, and this man is distracted, and he starts following the maiden's dance steps. As she dances, he's also dancing. And when she's dancing, she places her hand on her own head. This man forgets that he's got this bone, places his hand on his head, and he falls dead. Many people who hear the story say, what is this? Such a silly story. What does it mean? Surprisingly, it is encoding the story of Uttarayana and Dakshinayana. What are these things? These are concepts known from Vedic times. It is mentioned in our texts like Surya Siddhanta. It is also mentioned in Bhagavad Gita, for example, that 6 months is a northward course of the sun and 6 months is the southern course of the sun. And we know that, right? Because of Earth's tilt at 23 degrees, we observe that the sun appears to be going north and north and north as a consequence of Earth's rotation and revolution of the sun. Eventually, you see that it's retreating to the south. We see that. So this story is such that this person who's chasing Rudra is another proxy for the sun. So when the Ashura, who is another name for the wolf is a nocturnal animal. It sleeps during the day and hunts at night. So when the wolf is chasing Rudra, basically the sun is running away and the nights are becoming longer and longer. Or the day of Uttarayana, this Ashura is killed and Rudra can return back. So the sun is becoming longer and longer. So it's a simple story, but it encodes these facts of Uttarayana, Dakshinayana. So this is encoding, like I said, about solstice, equinox. And from an understanding of this, our ancestors knew what is the meaning of solar year. You might wonder, how did our ancestors know that the solar year took 365.24 days? Did they know about the heliocentric model? Did they have telescopes? All those kind of questions. Well, you don't need that. In your house, if you have an east-facing window, then every day at 8 o'clock in the morning, you see where the extreme rays of the sun is coming into your bedroom, and you make a chalk mark over there. And pretty soon, after you see that the sun is going north and north and north to northernmost point, then 6 months later it retreats and goes to southernmost point. So just by looking at this behavior of the sun, you'll understand one full cycle is done when it comes back to the original position. That is how our ancestors knew about the duration of solar year. Then there is another story that people have talked about. You're aware of this. I've talked about this quite a bit. It talks about, for example, in Matsya Purana and other Puranas, Chandra, whose moon, he married the 27 daughters of King Daksha. And people find the story so amusing, saying Chandra is not a man, and how is this possible, and all this kind of things. But our ancestors were trying to encode the movement of the sun, the moon in the sky. That is what they were trying to do. So these are basically the model of the nakshatras that is going to come over here. And it tells us that Chandra would visit a house each day. Because there are 27 nakshatras, that means it is related to the 27.3 sidereal month. What does this mean? Our ancestors noticed that every day the moon is rising in the eastern horizon at a slightly different time. And because it's arising at a different time, at nighttime especially, you can see that the star in the backdrop is different each day. Today, if there is one star over here, tomorrow it rises about 45 or 1 hour later, then you see that's a different backdrop of the stars. And our ancestors saw it takes 27 days for this moon to come back to the same backdrop of stars. That is why they divided the entire ecliptic into 27 segments of 13 and 1/3 degrees each. If you take 13 and 1/3 and multiply it by 27, you'll get 360 degrees. So that is what they did. And it encodes the fact that the moon traverses 13.3 degrees in the sky in a 24-hour period. What does that mean? When you see the moon rising today, for example, you'll see that it seems to be going from east to the west and it is set. But what do I mean that it covers 13.3 degrees in the sky? It means today at 10 o'clock in the night or whatever, you see where the moon is. Tomorrow at 10 o'clock at night, if you see where the moon is, it'll be behind by 13.3 degrees. That means it has covered 13.3 degrees in the sky. That is the meaning of that. And we have mnemonics for nakshatra names that helps us to keep the passage of time. So we are also told that in that story, the moon's father-in-law, Daksha, he was unhappy with the son-in-law, Chandra. So he curses it. He says that you're going to fade away and die. And Chandra does not want to die. So he runs out to Mahadeva and prays, Mahadeva, I don't want to die. Please save me. Mahadeva says, I cannot remove the curse, but I'll change it. You will instead experience a life of waxing and waning. As you die, you will eventually regrow to your full strength. So this is related to the 29.5-day synodic month. Earlier one was called sidereal month at 27 days. And this is called synodic month with 29.5 days. This is related to the tithi or the phase of the moon. And we're going to see this presently. So this is what I meant. From new moon till new moon, it takes 29.5 days and is called a synodic month. Whereas for the moon to come back to the same backdrop of stars, it takes 27.3 days. So this is called the sidereal month. And our ancestors were fully aware of both of these ways of marking time. You could mark time by the nakshatra of the day, or you could mark time by tithi also, which is the phase of the moon. They were aware of both of these, and very, very important to understand this. So our ancestors understood sidereal month, synodic month. They understood this Dakshinayana, Uttarayana. They understood the solar year, and they tried to find patterns. They tried to find patterns and reconcile it. That was the greatest intellectual development of our ancestors in mathematics and astronomy, trying to find where the synchronisms happen and so on, all the way from simple calendrical Adhika Masa to different yugas, 5-year cycle, 19-year cycle, Samvatsara cycle, all the way to Chaturyuga cycle. These are all the intellectual accomplishments of our ancestors to understand the skies. So you can say that the Indian astronomical model is one of nakshatras and Rashi. We've already told you, right, what the story tells us. So the nakshatra is a division of the sky in 13 and 1/3 degree segments. And these are the nakshatras in this outer circle, as you can see. For example, Chitra, Vishaka, Jyeshta, and so on. These are all the nakshatras over there. And our ancestors also had the concept of a lunar month. What was the meaning of the lunar month? In some parts of India, if the full moon appears over a certain nakshatra, that will give the name for that month. For example, if the full moon appears in Chitra nakshatra, that month is called Chaitra Masa. In some parts of India, full moon was used. In some parts of India, like southern India, Amavasya, the new moon was used. That is why you see this offset. It is offset by 15 days. In some parts of India, this is the Chaitra Masa. In some parts of India, this is the Chaitra Masa. Slight differences there. Our Indians also wanted to mark the passage of the sun. How do you track the passage of the sun? In order to do that, they divided the entire ecliptic into 12 segments of 30 degrees each. And these are the famous Rashis that you see. So this is what we had. We had the Rashi and the Nakshatra model. And we can see all the nakshatras in our ancient books. For example, Vedanga Jyotisha, Surya Siddhanta are two of our very, very ancient books. And you can see they have the same names literally, Kritika, for example, over here. And the principal star, when the British came, they wanted to understand from the Vedic Pandits, what is that nakshatra? They pointed out to each nakshatra, and the Pandits said what it was. They mapped it to the Western names. For example, Kritika is Eta Tauri, Rohini is Alpha Tauri, Mrigashira, Lambda, Orionis, and so on. So this way, we know, depending on the constellation, what is that particular nakshatra. Very, very interesting to see this. You might also wonder, how old is our nakshatra model? When did our ancestors get this nakshatra model? I cannot give you an exact date, but we look for evidence, right? So we know that at least as old as Atharva Veda, if not even more ancient. In Atharva Veda, we find that the nakshatra names appear fully developed. So we find that as old as Atharva Veda is. Your next question in your mind should be, how old is Atharva Veda? I'm not going to talk about that today, but we'll talk about other antiquity. Even in Rig Veda, if you go to Rig Veda, we see the beginning of mathematical astronomy. Not only were our ancestors observing the skies and making stories to pass on the wisdom, but they also started incorporating mathematics. Where is the evidence for that? Rig Veda, for example, in this verse 125.8 is saying, Varuna knows the 12 moons. What on earth is 12 moons? Well, this is referring to the 12 29.5 day synodic months. We talked about synodic month, right? So it's referring to that. So we see that over here. Another place, it is saying the wheel of time has 12 parts, 360 spokes, 720 pairs of day and night, with a remainder of 5 days. In another place, it says Vishnu or the sun sets in motion the wheel of 120-day periods. This is a reference to 3 seasons. So clearly, we are seeing that some kind of mathematical numbers are also there in the Rig Veda. It is the beginning of our mathematical astronomy, which went on to great extents later on. I'm not going to read all these things, but Rig Veda is also trying to encode complex information on how the sun cycle is, what the moon cycle is, and how we can synchronize them. For example, there is a verse that says 3,339 devas worship Agni, who is a lord of the seasons. And there are several people who are decoded. What does this number mean? It's like a magical number. So let us not go into details, but it is enough to know that our ancestors tried to see the cycles between the sun and the moon by doing these kinds of things. So before I put you all to sleep, I hope you've seen that there is evidence in archaeology, there is evidence in our texts, there is evidence in Atharva Veda, there is evidence in Rig Veda and others for the practice of astronomy going to an extremely ancient period of time. We saw there is something called synodic month, which refers to Tithi or the phase of the moon. We saw there's something called sidereal month that is referring to nakshatras. We saw there's something called solar year from the Uttarayana, Dakshinayana. We know what this is. So do we have evidence that in ancient India, we had calendars and coordinate systems, measurements? These are things that will be in everybody's time, right? Well, even today in traditional Indian families, we mark the passage of time using the Panchanga. So the Panchanga, as it says, 5 parts are there. The basic unit of time is a Muhurta. A Muhurta is 1/30th of a day, or in our modern measurements, 48-minute interval. Every 48-minute interval is 1 Muhurta. So we have Today, if I ask you what is the time, you'll tell me the hour, you'll tell me the minute, you'll tell me the second. You may even tell me the weekday. You may even tell me what date it is in the month, what month it is, what year it is. So that is how we mark time. Ancient India to present day, we have 5 dimensions. What is the nakshatra of the day? That is sidereal measurement. What is the tithi of the day? That is synodic. What is the weekday? Vara. What is the angle between the sun, computing the tithi, that is called yoga, and karana, that is tithi by 2. And in India, day begins at sunrise when all of these things are determined. And as far as the tithi is concerned, your textbook also talks quite a bit about it. So you have from the dark fortnight to the bright fortnight, it goes through starting from the initial phase of the moon all the way to, from Amavasya to this phase and all the way to Purnami. So I won't go too much into this. It's already there in your textbooks. We also have the concept of weekdays. Where is the evidence for that? Evidence for that is in Aryabhatiya, which is written by Aryabhatta, as well as Surya Siddhanta. So we have the days of the week referred to the sun, the moon, Mars, Mercury, Jupiter, to Venus, to Saturn. So this is the names that we have given. And the reason why these names are given is explained in Aryabhatiya as well as in Surya Siddhanta. We needn't go into great details of this other than to know the 7-day week is already known in at least Aryabhatta's time, at least Surya Siddhanta's time. And like I said, we also have the notion of solar and lunar months. So the solar months are referred to the Rashi, like I said. In 30 days, the sun seems to enter into one Rashi. This is what we call Shankranti, for example. And so we have from Mesha, Vrishabha, and all these Rashis over here. And the lunar months, already talked about. Some parts of India, when the new moon appears over a nakshatra, that is the lunar month. In some parts of India, when the full moon appears over a nakshatra, that is the lunar month. So we have concepts of all of these things. So knowing that, we can now start talking some mathematics, right? You all love mathematics, I'm sure. I hope none of you are yawning over there. I can't see you all, but hope you're not yawning. So anyway, we have, for example, we learned that one muhurta is 48 minutes. So in a day, we have got 30 muhurtas. It is called an ahoratram, or a sidereal day of 24 hours. If you take 30 ahoratrams, we get one masa. So we know that 30 tithis is nearly 29.5 days, which is a synodic month. If we take 2 masas, we get 1 ritu, or a season, which is approximately 60 days. If you take 3 ritus, that is 1 ayana, the movement of the sun to the north or the south, that is called an ayana, which is around 180 days. If you take 2 ayanams, we get a varsha, a lunar year of 360 days. At this point, you children must be very confused, wondering 360 days, but we have learned that the year is 365.24 days, right? Were our ancestors fools? Did they not know this? And what happened to the remaining 5 days? Well, actually, they were not fools. They knew about it. Rig Veda is talking about a year of 360 days. We saw that. But then in very ancient times, very, very ancient times, they would practice something called an Atiratra Yajna. That sacrifice would be done for 4.5 to 6 days. During that time, they don't count the passage of time. That was done to get synchronization between the lunar and the solar calendar. But then we also have in Rig Veda and Atharva Veda that the Rishi called Rohita, he created the Adhika Masa. This means some Rishi has found the formula how to figure out whether to have an additional month in the lunar calendar so we can have synchrony between the solar calendar and lunar calendar. So we know that if you add an Adhika Masa every 3 years or so, then you can have, on the average of 3 years, the number of days considered in the solar lunar, they'll be similar. So this Rishi, Rohita, has got the mathematical formula on how to create Adhika Masa, and Atharva Veda is informing us about it. This is also mentioned in the Rig Veda. So we know that even from as early as Rig Veda or Atharva Veda, our ancestors have known how to synchronize between lunar calendar and solar calendar. The evidence is there in all of what I'm showing you. And we know that different parts of India, we have different calendars. For example, if you take a look at this chart over here, so we got in some parts lunisolar calendar, some parts solar calendar, and since 1957 we have the mathematical calendar. So the lunisolar calendar, we have Amanta or Purniyamanta. Amanta means the month is calculated from new moon to new moon. Remember I told you when the new moon is there over a certain nakshatra, that is the Amanta month starts over there. In some parts of India, Purni, that means Paurnami should be over a certain nakshatra. That starts the beginning of the month. So the Amanta is used in southern India, in western India. Purni Amanta is used in northern India. Solar calendar is used in the Malayali calendar, Oriya, Tamil calendar, Bengali calendar, and so on. And this is what we have. And this map over here shows you the same thing. The blue is a Purni Amanta. You can see Madhya Pradesh, Rajasthan, Haryana, all these places we use Purni Amanta calendar. Then the orange over here is Western Amanta in Gujarat. In southern India, we follow the Southern Amanta calendar. We also follow the solar calendar in Kerala, Tamil Nadu, in all of these places. In Bengal, we follow the solar calendar. So we know that the concepts are the same, but different parts of India. India is a huge country, right? Very ancient civilization. That means regional divergences have happened over time. That is why we see these different practices in different parts of India. And we also have, if you go to the Purana, something called the solar dynasty and the lunar dynasty. You might have heard about that. This is referring to people who followed one kind of calendar over the other. The solar dynasty would follow the solar calendar, lunar dynasty, a different kind of calendar. We also have in India something called a Samvatsara cycle. This is a 60-year cycle. Our ancestors had seen that it takes 30 years for Saturn to come back to the same zodiacal plane. It takes 12 years approximately for Jupiter to come back to the same zodiacal plane. So if you take 30 times 2 or 12 times 5, we get a resonance of 60. So every 60 years, Jupiter and Saturn will return to the same zodiacal plane. So that is one more synchronism that our ancestors observed and said, hey, let us mark that also as yoga, as a way to mark the passage of time. So currently, we are in the 37th cycle of the current Samvatsara cycle. Going back to very ancient period of time, we have been following this. We also mark era. What is an era? If I ask you what is the date today, some of you might say it is 2023, year 2023. With respect to what? With respect to the marking of time about 2023 years ago, the common era, we are saying that's the passage of time. In India, we have had different markers. The Kali Yuga marker going back to 5,000 and odd years, Buddha Nirvana, or going to Shaka era, Gupta era, Shalivahana era. So we measure time in different parts of India with respect to these different markers. We say so many years have elapsed. So what we are seeing is Indians have a very well developed idea of how to mark passage of time. They know about nakshatra, sidereal month, synodic month, Uttarayana, Dakshinayana, solar year. They know that. They know how to synchronize these things with Adhika Masa. They know how to call out the time in the particular week. What is a month? What is a week? Day? What is a day? In the day itself, what is the muhurta? Up to the muhurta, they're able to tell you what is the passage of time. In addition to that, they'll tell you how many years have elapsed from certain marker like Kali Yuga. So what we see is very mature and well-defined, understood concepts of time in ancient India. So with that, I'd like to take you to some other interesting things. I hope you children will find this interesting. Did you know that Indians might have observed galaxies? I am not going to go there today, but I will show you other things that Indians observed, comets to galaxies, for example. We know Indians have observed solar and lunar eclipses. For example, in Rig Veda, there's a reference to Rishi Atri. Atri has referenced doing something amazing. I'm going to call it out later, but he was able to actually measure the solar eclipse. We'll talk about that presently. Then many people said the language used in Rig Veda is something called Rahu which is like a demon that is swallowing the sun, and Ketu. It talks about these two kind of entities. And people used to mock Indians, saying Indians were so superstitious. They didn't understand what eclipse is. They thought eclipse means a demon is going to swallow the sun. But actually, no. Aryabhatta showed in his work, Aryabhatiya, a lot of things. He said, if you look at how the sun is going, if you think that you're on Earth, you're observer on Earth, you're observing the sun going on a certain path. The path of the sun is called the ecliptic. If you see the path of the moon, it does not follow the ecliptic exactly, but it is offset by 5 degrees. So this is the path of the moon, this is the path of the sun, and the angle between them is 5 degrees. Because of this angle, we can only have eclipses when you have these nodes coinciding. So if the sun and moon coincide here, that will give us a solar eclipse. If the moon is here and the sun is there, obviously we are on Earth like this, then we'll have the lunar eclipse over here. Aryabhatta explained these things. Not only that, he also gave formulas that said, what is the length of Earth's shadow? How big will Earth's shadow be? How big will moon's shadow be? Will moon's shadow fall on the Earth? How long will the eclipse last? He's actually got formulas for all these things. Nearly 2,000 years ago, our ancestors were that advanced, they could do all of these things. Aryabhatta referenced these ascending and descending nodes as Rahu and Ketu, clearly explaining the mechanisms of our rishis. I will explain this a little later on also. Indians also observed something called precision. I'm going to talk to you in a little more detail about this later, so I'll skip this slide for now. Then they observed something called transit. What is a transit? The inner planets. You know what the inner planets are. Inner planets are, you have Venus and you have Mercury. So these two planets are closer to the sun. So whenever we look towards the sun, that is when we can see these planets, maybe in the evening time or maybe early morning, the dawn. For a brief period, you can see these planets when the sun is not risen yet. But sometimes, from our perspective, these planets go across the face of the sun. That is called a transit. For example, you may not be able to see it on your screens there, but there's a tiny dot, black dot here. So this is a picture that I took, a photo of the sun with Mercury. Mercury is transiting in 2016. You see that little dot, Mercury is going across. Our ancestors have observed even transits. They were able to estimate when a transit would happen and so on. So in the West, only after Galileo, he had a telescope and Kepler got a lot of data. Only then Europeans were in a position to say, yes, Mercury is going to transit the sun. They could not do that earlier. But for our ancestors, this was routine because of the models they had. They knew about transits. We have evidence of these things. Indians also observed planetary conjunctions. This is there in Surya Siddhanta. It calls it a yudh. Yudh means two of them coming for a fight nearby. So recently we had Saturn and Jupiter coming close to each other, right? This is a picture that I took at that time. So our ancestors observed conjunction of planets or planets with the stars or with the moon. And so these things are also observed. They also observed occultations. Occultation is, from our perspective, when the moon goes across the face of a star, so we can't see the star or planet, that is called an occultation. Here is an example of moon occulting Kritika Nakshatra in 2006, January 9th. So our ancestors have observed this in addition. They also observed comets, many comets. Comets are called Dhumaketu, and we have references in ancient India in the Rig Veda, Ramayana, Mahabharata, Parishara Tantra, Vriddhigarga, Varamira. Even in Sangamira Tamil works, we have references to comets. So unfortunately, we don't know what these comets might be because the dating of our texts are also uncertain. But from 12th century onwards, we can say which comet it was based on periodicity of the comets. We can say that. So, children, I want you to think for a minute. I told you that our ancestors were advanced in astronomy. They made many observations. They observed all of these things. So you can ask the question, how long has this been going on? What is the antiquity of Indian astronomy? How old is it? Well, to talk about antiquity, you must first understand what our Earth is doing. If you see this picture, this graphic over here, the Earth is undergoing 3 cycles, 5 cycles for you. One cycle is rotation. You know that once in 24 hours, Earth rotates on its axis. You also know Earth goes around the sun once in 365.24 days. In addition to that, the Earth's orbit around the sun goes from elliptical to circular. Do you see this? Elliptical to circular. This takes 100,000 years to complete, 100,000, 1 lakh years to complete. It is also doing something called axial precession. Axial precession is like if you play it with a top is a pambaram, right, in Tamil. So you take a top and you play it, you pull the rope like that, the string. The top spins very, very fast. But as it is spinning, it might do a small wobble sometimes. Can you visualize that? The top is wobbling also. So the fast spin on the Earth is 24 hours, and the slow wobble is called axial precession. It takes 26,000 years to complete. Then even the axis of rotation, where is it pointing? That also changes in the sky in obliquity from 21 degrees to about 24 degrees. Right now it's 23 degrees. This takes 41,000 years. Because of this second one, axial precession, the nakshatra that is there at an equinox point or at a solstice point will not be the same after several thousand years. So if we know the observation that our ancestors made, we can then try to use mathematics to see at what point in the past did axial precession allow these measurements to be made. I know it's a little difficult to understand, but if you look at these pictures, hopefully it will make a little more sense. So how do we do dating using Indian astronomy? I showed you the precision. It is taking 26,000 years to complete. All of you are on the 11th standard, right? So you can do simple algebra and mathematics. If you take 26,000 and divide it by 360 degrees for one full circle, you get that in 72.2 years, that precision rate was 1 degree. Or in terms of nakshatras, how long does it take to traverse one nakshatra? 26,000 divided by 27, 963 years per nakshatra. Or for a Rashi, 26,000 by 12, 2,166 years per Rashi. So if somebody says Rama was born in Chaitra Masa, what does that tell us? It means the full moon was in the Chitra Nakshatra and the sun was 180 degrees opposite to that, opposite in Ashwini Nakshatra. That is why from opposite 180 degrees shining on the sun. So that's why we see a full moon. So just by saying one statement, Rama was born in Chaitra Masa, I have got 2 data points. One is full moon is in Chitra Nakshatra, sun is in Ashwini Nakshatra. If somebody says Varsha Ritu began in Ashada Masa, that means the full moon was in Ashada Nakshatra, sun was in Punarvasha Nakshatra. That is when rainy season happened. But today in India, rainy season happens when the sun is in Mriga Nakshatra. There is 2 nakshatra difference because of precession of equinox. So I can use the same precision rate, approximately 963 years per nakshatra, multiplied by 2, and I get approximately 2,000 years ago, the statement was true. And who wrote this? Kalidasa. Kalidasa wrote it in Meghaduta about this Varsha Ritu began in Ashada Masa. So just by reading that one line, it tells me that this was written 2,000 years ago. This is how we use clues from the past to do the dating of Indian texts and other works. We have a very ancient text called Vedanga Jyotisha. So several people tried to give a date. How old is Vedanga Jyotisha? This Weber said 500 BCE, William Jones 1000 BCE, Lokmanya Tilak and others. Eventually, Dikshit, who was in 1850 or so, he said it has got to be dated to 1400 BCE. And how do we work with this knowledge? What do we do with this? Vedanga Jyotisha has got a statement in verse 6. It is saying winter solstice occurred when the sun and moon came together in Dhanishta Nakshatra. What does that mean? When winter solstice happens, then the sun and moon should be in Dhanishta Nakshatra. That is when Vedanga Jyotisha's period is. We can date this using our astronomy software. using planetarium software, for example, which is mathematical software, we are able now to see when was winter solstice happening in Dhanush Nakshatra. What you're seeing here is a projection of Earth's latitudes and longitudes on the sky. Okay, so this point over here is the celestial North Pole. And these circles are the celestial latitudes. These lines are the celestial longitudes. So if this is 90 degrees, this is 80, 70, 60, 50, 40, 30, 20, 10, 0. 0 on Earth is the equator. In the sky, it is called a celestial equator. Then this is minus 10, minus 20, minus 23 or 24 degrees. So that means sun has gone to southernmost point. When the sun goes to southernmost point, it is winter solstice. And when it is winter solstice, what was the longitude? You see Dhanishta Nakshatra is over here. So this date is 1440 BCE. You must crank back in the planetarium, must go back so many years before you find sun in the Dhanishta Nakshatra. So from this, we know Vedanga Jyotisha is a very ancient astronomical text in India, whose date is approximately 3,500 years before now. I told you the story of Dhruva, right? So in the story of Dhruva, Vishnu says, I will make you into a star in the sky, around whom all the other nakshatras will go. But he also says one more thing in Vishnu Purana. He says, your mother, Suniti, will be near you. If you look at the sky today night, if you can find out where Dhruva is, look in the northern sky. In Tamil Nadu, it is approximately around 10 degrees from the horizon. That's where you'll find Dhruva. So if you look for Dhruva, you'll find there is no nearby star to Dhruva anywhere nearby. So this is very surprising. Did Vishnu lie? Did Vishnu say a lie saying your mother will be nearby? What happened over here? Well, precision is what happened. When the Vishnu Purana was written, the pole star was Thuban, another star called Thuban. Near Thuban, we find is a companion star. So the rishis who wrote this, Vedavyasa, essentially, this is what they saw, and they wrote this. But in 5,000 years, things have moved, and we don't find the star anymore, the pole location. At the pole location today, we got Polaris. Polaris is what we are calling Dhruva today. But 5,000 years ago, Thuban was Dhruva. So just by the story that is there in Vishnu Purana, we know that Dhruva story is approximately 5,000 years before present. I hope your children are understanding this. I know it's a little difficult, but if you pay attention, you might be able to get this. We have one more famous rishi called Yajnavalkya. Yajnavalkya wrote this work called Shatapatha Brahmana, in which he made a statement. He was telling the Vedic practitioner, he was giving him formulas. He's saying, this is how you must conduct a yajna. This is how you must put the bricks. And he also told them how to face the east direction. If I ask your children, where is the east direction, you're going to laugh at me, right? You'll say, what a silly man he is. Wherever the sun rises, that is where east is. But children, that is not true, because Uttarayana and Dakshinayana, the sun is going to go south until the minus 23 degrees south. Then it is going to go north 6 months till 23 degrees north. So where is the east direction? Is it here, 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 and here? No, only on the day of the equinox, when the sun is in the celestial equator, that is true east. And so that is what the Rishi is saying. Kritika Nakshatra, which is Pleiades, never moves away from the east direction. So he said, you can set up your yajna under Kritika and light your homa, fires under over there. That is what he said. So we have to see when was Kritika at the equinox point, because today Kritika is not at the equinox point. So to do that, we must crank it back in time by approximately 2982 BCE. What you see here, again, this is 90 degrees, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. 0 is a celestial equator. Remember, I told you that the sun will be exactly in the celestial equator on the equinox date. So when the sun is the celestial equator, we are seeing that Kritika Nakshatra is over here, heliacal rising. So this is what Rishi was talking about, which means Shatapatha Brahmana should be dated 2982 BCE. Then we have many, many references to Kali Yuga, whether it is Aryabhatta, whether Surya Siddhanta, Pulisa Siddhanta, Brahmagupta, Al-Baruni, or in the Aihole temple in Karnataka, And many places, even the British had observed this, Playfair, Bentley, Colebrooke, Burgess, and Surya Siddhanta, and they all determined that this date seems to be referring to something in February 18th midnight, 3102 BCE. It turns out to be a rare clustering of all the planets, sun and moon in the Revati Nakshatra. Our ancestors have always marked this. For example, the Surya Siddhanta, based on the data over here, Burgess in 1935 is referring to this particular event. And we see that I've shown the planetarium software. The sun is over here, Revati Nakshatra is here, Chandra, moon, Guru and Shukran almost on top of each other over here, and Mangala, which is Mars, Budhan is Mercury, Shani is Saturn. Everything is clustered over here. Such a clustering happened in February 18th, 3102 BCE. Since then, such a clustering has not happened. So our ancestors are referring to this. Even today, devout Hindus who start their prayers, they say, how many days have elapsed since Kali Yuga? That is the way we do our prayers even today. So very, very interesting to see this. Then we have a story in the Rig Veda that is talking about Aditi. Aditi is the mother of gods, right? So she is in many works, whether it's Rig Veda or Aitreya Brahmana, Taittiriya Samhita, they all talk about Aditi. But I'm going to reference Aditi from this Aitreya Brahmana. In Aitreya Brahmana, in this translation, you see the yajna, the sacrifice, went away from the Devdas. Devdas are the gods. The gods were unable to perform any festival or ceremony. They did not know where it had gone to. They went to Aditi and said, let us know the sacrifice through thee. Aditi said, Tatastu, let it be so. But I will choose a boon from you. They said, choose. She said, all the yajnas will begin with me and end with me. What does that mean? What does this cryptic line, the passage mean over here? It means even in an ancient period of time, our ancestors were confused by the sky. The sky was a calendar. In the sky, they saw whenever a nakshatra is at a certain point, that is the equinox time, or that is the winter solstice time, or that's the vernal equinox is the starting point of New Year in India, always. So that nakshatra that is supposed to be in vernal equinox has changed. If that has changed, our ancestors did not know, when do I start my festival? When do I end my festival? They didn't know anything. So it is referencing that they have reset the calendar to Aditi. So the new year is beginning with Aditi and ending with Aditi, 365 days, right? Comes back to Aditi. So this is because of precision. So we have to see when was Aditi at this vernal equinox point. Aditi is referenced today as a Punarvashu Nakshatra. You can see two stars here, right? This is Diti and Aditi. In the Greek tradition, this is called Castor and Pollux. These are the two stars, Castor and Pollux. This is the sun's equinox point, a vernal equinox. So if you had to find out when was the sun at the time of vernal equinox in the Aditi or in Punarvashu Nakshatra, you must go to 6000 BCE, which is approximately 8,000 years. 8,000 years from before, our ancestors have already been confused by the sky. They've already had a calendar that looks at the sky when the equinox is. They know precision, something funny has happened in the sky over thousands of years, and they know they have to reset the calendar to Punarvashu Nakshatra. That is what we are learning from this. This is the evidence for these things. Then Surya Siddhanta is also saying all the planets were once clustered in the Mesha Rashi. So this we can see Surya Siddhanta's reference to 6779 BCE, February 22nd, when Sun and all these planets are clustered over here in Mesha Rashi, or what we call Aries today. It is clustered over there. So all these things, children, should tell you that the text that we have, whether it is the Rig Veda, whether it is the Shatapatha Brahmana, whether it is the Puranas, they all contain references to astronomy. If we understand this precision phenomena, we can date it rather accurately. And we have very, very ancient dates like 8,000 years, 7,000 years, 5,000 years. So it is telling us that our ancestors have practiced astronomy for at least so many years. Okay, with that, I'd like to tell you one more thing. Did your ancestors have any idea about measuring celestial phenomena? I already told you about Aryabhatta. I already told you about Rig Veda that is talking about mathematical astronomy. Today, all of you have got a geometry box, right? I'm sure if you open your school bag, you'll find I used to carry a Camel. You remember the brand Camel geometry box that used to have a compass, protractor, and all those kind of things? So, did our ancestors have any of these things? Did they measure the skies using geometry? That is the question. So let us look at the evidence for that. There was a Britisher called Colebrook. So he read a lot of ancient Indian Sanskrit texts and translated them into English in 1799 in Asiatic Researches. And over there, he's saying Surya Siddhanta is referencing an instrument, a spherical instrument called Gola Yantra, using which they were able to look at Revati, and they were able to a star called Revati and try to make some measurements and so on. So this is there. Reference is there in Colebrook's works over here. That is telling us that Indians had something like this. And I will show you what this is. Do you see this? See this on the camera? So this is a kind of astrolabe using which our ancestors could figure out various things that are happening, a lot of measurements and so on. That is what I tried to show you over here, one such instrument. This is not exactly this instrument in ancient period of time, but they used to have things of that nature. So I'd like to tell you something amazing. I told you earlier about Rishi, the Rigvedic Rishi Atri, who observed a solar eclipse. This is referenced to in the Rig Veda 5.40.6. It is talking about Atri and is also making reference to something very strange called the Turiyena Yantra. So this was decoded by Professor Ludwig, a German who had studied this. He said the Rig Veda is mentioning inclination of the ecliptic with the equator. How is where is the celestial equator and where is the sun's path? What is the inclination? If you had to do that, you must have some measurement device, right? What kind of measurement device is there in the Rig Veda? Then Tilak is referencing this Atri's measurement and saying that Turiya Yantra was a quadrant. A quadrant is something like this. This is a modern, not modern, in the 18th century. This is a quadrant where it is like a compass protractor with which you can look at the sky, measure an angle. Angles were important, for example, the angle between sun and moon for the tithi and things of that nature. In this case, Atri seems to have used a quadrant. Why would you use a quadrant? You'd use a quadrant to measure the angle and know that you can predict when the solar eclipse had happened. So this amazing thing tells us that maybe in Rig Vedic times itself, our ancient Indians had instruments with which they were measuring the skies. In the West, it's only from Ptolemy who used a quadrant similar as the Rig Vedic quadrant to measure the skies. In Muslim world, in Turkey, also they made these huge quadrants using which they measure the skies. This is in China. In the 16th century, they had this huge geometrical device to measure the skies. And clearly, Indians had this earlier too. So we have evidence today in archaeology with 5,000 years of instruments used to measure the skies. Harappa, that is talking about water clocks. Water clocks are also there in Vedanga Jyotisha, 1400 BCE. Aryabhatta is talking about things like Chaya Yantra, Dhanur Yantra. All these are different instruments, just like you have compass, protractor, and all these kind of things. They had these things to measure the skies. Varamira, in addition to this, he also did graphical calculations. Today, you might use a graph to have an XY graph, mark the points and draw a graph, right? Varamira was doing such things, graphical calculations. Brahmagupta also had several ones. Bhaskara talked about a circular platform. I found this in Lothal. How many of you know where Lothal is? I'm sure several of you know, right? If you've gone to Gujarat, if outside Ahmedabad, you find the ancient ruins of Lothal, Harappan city. There I found this, where there are circular brick platforms and nobody knows what it was used for. But then Bhaskara is saying it was used for astronomical purposes. So that is there over here. Then by the time you come to Lalla, they're using armillary sphere. This is the armillary sphere that I talked to you about. Lalla was using something like this to make measurements. And we have Mahendra Suri. And by the time you come to European times, Jai Singh, you have gone to Jantar Mantar in Delhi or Jaipur, you have seen that Jantar Mantar using European instruments to do that. Very interesting. So our ancestors knew the cardinal points of astronomy. Where is the winter solstice, summer solstice, vernal equinox, autumn equinox? I showed you even in Andhra Pradesh, they were setting up these huge stone pillars, megalithic pillars to mark these things. They knew reference plane, where is the horizon, ecliptic, equator. They knew the celestial poles, north, south, east, west, zenith, all these things. From these, they were able to make a coordinate system. You know that in geometry, you need a coordinate system if you want to measure the skies. So clearly, our ancestors had observed the skies. They have got instruments using which they're measuring the skies. They had mathematics to do all of the things that they wanted to do. So our next question is, same Milankovitch precision. Our ancestors, did they notice precision that things are changing? If you say equinox happens during a certain nakshatra at that point, 500 years later, 1000 years later, that will no longer be true. Did our ancestors know that? Did they measure precision? That is the question. And the answer is a big yes. In Surya Siddhanta, we have a reference to precision over here. And this is from Dr. M.L. Raja, who is a professor in Avinash Research in Coimbatore. So he says from Surya Siddhanta's data that in a yuga of 4,320,000 years, the Surya Siddhanta is saying it completes 600 revolutions. So if you divide these numbers, you get 7,200 years per revolution, what the Surya Siddhanta is referring to. And Indians call this something called Ayana Chalana. Ayana Chalana referred to precision. So in 1 year, the 600 revolutions times 27 degrees, that is what Surya Siddhanta is saying, it moves by 27 degrees. There are 4 segments, like a sine wave, 1 segment, 2, 3, 4 segments. Multiplied by 60 degrees to convert it to degrees to minutes, and multiplied by 60 to convert it to seconds, and divided by the number of years, we get 54 arc seconds per year. This is the number encoded in Surya Siddhanta for the precision phenomena that I talked to you about. Very, very interesting to see this. And children, you might be interested in knowing, okay, if Surya Siddhanta talked about this, did people in other parts of the world, did they also know that? Surya Siddhanta said 54 arc seconds a year. We know that it is the same figure as there in Parashara Tantra Siddhanta going back to 1400 BCE. Also says 54 arc seconds a year. I think it has got the same figure as Surya Siddhanta. Then in the Western world, Hipparchus in 120 BCE, he said it is 36 arc seconds a year. So much in error, but he copied the same number as Vriddhigarga, who lived in 800 BCE. In China, Yuxi in 307 current era, he said it is 72 arc seconds a year. Aryabhatta, he had got it to 48 arc seconds a year, much, much closer to the real number, which is 50 arc seconds a year. Then the Arabs, they copied Surya Siddhanta, so it is 54 arc seconds a year. Then by the time he came to Bhaskara II, he got it 48.6. And in Odisha, Patani Samanta Chandrasekhar, he got it to 49.179. The modern figure is 50.4 arc seconds a year. Children, if you take your fist, make a fist, and hold it at your arm's length and look in the sky, you're extending 10 degrees in the sky, okay? If you extend just your tiny finger in the sky, that is approximately about 1 degree in the sky. Now, can you imagine they are measuring not 1 degree, not 1 minute, but they're measuring 50.2 arc seconds in a year. That is how much the movement is. Our ancestors were capable of measuring something that is so precise. That is what I want to emphasize to you. Again, think about it. Take your tiny finger, hold it out at arm's length, and it is extending, whatever is extending the sky, that is the 1 degree. From that, you divide it by 60 and so on, you get an idea of how tiny the movement is per year. But then that is what our ancestors measured. So what I've told you is our ancestors observed the skies. I've shown you evidence of that. Then I told you that our ancestors had instruments. Starting from Atri onwards, I gave you names of various astronomers who had talked about the instruments they had. So they were measuring the skies also. In your mind, you must think, If they were able to measure, if they're able to observe, then the next thing is were they able to predict with it, whether they're able to model it. Did they know what that phenomena is? Did they have mathematical equations? Were they able to use those equations to predict things? And the answer is again yes. If we look in Vedanga Jyotisha, 1400 BCE text, we find a mathematical formula here, which is very familiar to you high school kids over here, right? You've always seen A by B equal to C by X. A, B, and C are known. X is an unknown quantity. How do you get that? Cross multiplication. And you get the unknown quantity X is BC by A. Did you know where this came from? This came from the rule of three. Rule of three in Vedanga Jyotisha. That is saying the rule of three must be applied again and again. So in other words, he's saying that once you get a tiny result, you can apply the result again and again and again and get a linear prediction of this of what is happening. For example, if a planet moves in the sky, it moves by delta S units in a time delta T. They can measure delta S, they can measure delta T. Then they'll say, maybe tomorrow or maybe 2 days later, where will the moon be? Or where will the sun be? Or where will Mercury be? If they wanted to know that, how do they do it? They apply this formula over here. So the distance it will travel is delta S by delta T times T. And those of you who have done calculus in class and you're in high school, you should know what calculus is. If you take the limit of delta T as T tends to 0, you get ds by dt, right? So you're getting the elements of calculus is already there in 1400 BCE text. So they use this to predict where will the heavenly body be after a period of time. If I measured in maybe 2 days, Mars moved so much of distance, then in 1 month, where will Mars be? That is called a linear prediction of movement. And our ancestors were doing that way before anybody was able to do it in 1400 BCE. And the evidence is there in Vedanga Jyotisha, in these verses. There is also evidence in our mathematics that linear is not enough. The sky is not a, you can't draw a straight line in the sky and say, this is the distance from this star to star, because it is curved, space is curved, right? So we can't use linear measurements. We need to have a spherical geometry. That's what we need to do. So we know that ancient Indians invented the field of trigonometry. Westerners claim that Hipparchus is the one that is the father of trigonometry. But what did they have? The Greeks had chord table. This is a chord table. If this is a quadrant, then this is a chord, right? This is not trigonometry. You know that already. Trigonometry is right angle triangles. This is what trigonometry is. And this is described in Surya Siddhanta. Surya Siddhanta has got these things. Aryabhatta is providing trigonometric tables and so on. So we are seeing evidence that Indians have developed the field of trigonometry in order to understand how the heavenly bodies move in the sky. And we also know that they had complicated mathematics. I don't know if you covered these things in 11th standard or 12th standard. Maybe you have not done that. But Aryabhatta already had something called linear interpolation to understand functional approximation. By the time we come to Bhaskara the first, he's got an approximation for the sin x that looks like this quantity. Very, very accurate one. And by the time we come to Brahmagupta, who lived in around 600 in the current era and odd, he's got something called second order interpolation formulas, much more accurate formulas. What is this telling us? This evidence is telling us that our ancestors were measuring the heavenly bodies. They had models to predict how quickly will the heavenly bodies move. And there was errors in those measurements, errors in those predictions because the sky is not linear, it is curved. Because of that, they had more and more complicated mathematics. So what you should see, children, is mathematics grew in India because of astronomy. Astronomy was the application for which they wanted these things. By the time you come to Kerala School of Mathematics, Madhava has got infinite series expansion for sin x, cos x, tan inverse x, all these things. He's got infinite series expansion. It is a quest for accuracy. So I will end this talk by talking to you about how accurate Indian planetary modeling was. So the question first before that is, did Indians even know about the planets? There are some Western scientists who said that Indians did not know about planets. They only had certain ideas, but they did not know about planets. Well, if you look for the evidence, if you look at Parashara Tantra, for example, Professor Iyengar has written papers on this. So over here, we are seeing in this work that this dated to 1400 BCE, by the way, it's saying Mercury's paths are 7. It's talking about the path of Mercury. It says Jupiter travels 2¼ nakshatra in 1 year. This is a mathematical data point. It is telling us that it is leading to a 12-year sidereal cycle. Right, for Jupiter to go completely around for one revolution, we know that it will take 12 years. From this figure, you can figure that out. Saturn, it is saying it traverses through the 27 nakshatras for 28 years, almost 30 years. So clearly, there is mathematical data going back to 1400 BC, which Aryabhatta had used later on. And the same work by Parashara, you're seeing that the cycle of Venus, he's talking about the period of Venus as 591 days. Today we know it is about 584 days. So accurate figure was got by your ancestors going back 3,500 years. Surya Siddhanta, this has got a lot of mathematics. In verse form, it is talking about the revolutions of the moon, of Mercury, of Venus, and so on. So a lot of mathematical data over here. And this table helps you to understand that. For example, there is something called mean daily motion. It means how much will a planet move in a given day. So that is a mean daily motion, number of revolutions in a Mahayuga, divided by number of days in a Mahayuga, multiplied by 360 degrees, that will give us a daily motion. The sun goes 59 arc minutes in a day. If you multiply by 365, you get this the length of a year over here. Mercury in Surya Siddhanta is 4 degrees, 5 arc minutes. So similarly, so ancient Indians already by the time of Surya Siddhanta already have a lot of data points that talks about various planets. What is their time period? This is something you should be amazed about and proud about your ancestors, that they were able to measure these things to such a high degree. And if you look at the work of Aryabhatta, Aryabhatta has got highly accurate figures for the sun, moon, and other things. And if you look at Ptolemy, he seems to have similar figures too. So clearly, Indians, even before Aryabhatta, probably had these figures, which are used in Greece also in an ancient period of time. Indians used something called an epicycle model. Okay, this is a little complicated to understand, but today you know that the sun is at the center and all the planets are going around the sun, and that is called a heliocentric model. Indians probably understood that, but for purposes of measurement, when we look, the reality is the sun appears to be going around the earth, moon appears to be going on the earth from our point of view, observation point of view. So for the mathematical calendar, they took the earth as a center, moon is going around the earth, Mercury is going around the earth, but it is also going in a cycle by itself. Similarly, Venus, Mars, it has got a cycle. These cycles are called epicycles. Aryabhatta had that all the way to Bhaskara II. If you understand the mathematics of what they did, we see evidence of spherical geometry, trigonometry, measurement devices, prediction, tracking, mathematical equation modeling, error correction, approximation. All these things are clear if you look at the mathematics of what they did. So it is something to be amazed about that 2000 years ago, they were doing these things. Now, this is a researcher called Anil Narayanan. He wrote a research paper in 2011, and he wanted to compare how accurate is the Indian epicycle model. So he says that the Greek epicycle model was a constant radius. It had a constant radius for this cycle and for this minor cycle. Whereas the Indian epicycle had a pulsating one. Sometimes the radius shrinks, sometimes it expands, shrink, expand, shrink, expand. So he said Indians had a complex epicycle, Greeks had a simple epicycle. Then he tried to measure the accuracy. So this is the error in the XY graph that you see as a function of longitude. And he showed that in the year 100, current era, the Greek error is the dashed line and Indian error is the solid line. You see, it is very small in 100, whereas the Greek error is much larger. Then closer to our time, 2000 current era, you're seeing that the Indian model is got little more error, but the Greek model is far greater in error. This was observed even by the Britisher called Brennand, the colonial Britisher called Brennand, who studied this in 1896. And he said, if you reference the parameters given in Surya Siddhanta, it appears that it was composed around 3500 BCE. Think about it for a minute. He's saying Surya Siddhanta solar parameters were composed 5,500 years ago by the mathematics. Anil Narayanan did further study of that to see where will the error become the least in the Indian model. So this error is in 2000 current era, 100 current era. He went back in time 1000 BC, 2000 BC. Error is becoming smaller and smaller. Error became smallest in 5000 BCE. You can see this smallest sinusoid over here is around 5000 BC, showing the least error in the solar longitude. So what it is telling us is some of the models that are given in Surya Siddhanta are perhaps that ancient. We cannot tell it for sure, but this is what our mathematical reconstruction is telling us. Okay, this is something to be amazed about. So with that, I will come to closing my talk. I know that must be very difficult for you children to understand some of these things, but you are free to ask me questions. What did we talk about today? We discussed early Indian astronomy wisdom, that it is there in stories for easy recollection. We saw the story of Chandra, 27 wives, that is talking about sidereal month of 27 days. Then Chandra's waxing and waning, references synodic month of 29.5 days. Story of Vrika, Bhasmasura is referencing Uttarayana and Dakshinayana, solar year. Story of Dhruva, rotation of Earth's axis. Story of Aditi, precession of equinox. So we saw that stories are not just stories. They contain astronomical wisdom. We must understand what is the key to unlock the wisdom. If you don't have the key to unlock the wisdom, then it becomes a silly mythology. But if you have the key to unlock the wisdom, suddenly you say, aha, this is what my ancestors meant. There is so much wisdom over there. So very interesting to see that. Then we also discussed Nakshatra Rashi model, how it is used in calendars. We discussed various celestial phenomena observed by our ancient Indian astronomers. We discussed old Indian astronomy is. We saw the story of Aditi going 8,000 years before present. We discussed that Indians were using measurements of celestial bodies, lots of different measurements. We talked from Atri onwards, all the way down to Mahendra Suri and others. We talked about that. Then we talked about precision, measurement of precision by ancient Indians. How I showed that ML Raja is shown that in Surya Siddhanta, it is referring to 54 arc seconds a year. The modern estimate is 50.2 arc seconds a year. Very, very precise measurements done by our ancestors. Then we saw the Greek model and Indian model, how much more accurate Indian model is. And clearly, we are seeing that even if your textbook is talking to you about something called Aryan invasion theory in history in 1500 BCE, by the data that I've given to you by now, you should know that there is a big problem because our data measured from India is talking about antiquity in Vedic texts going back 8,000 years, 5,000 years, 7,000 years, whereas Westerners are trying to tell us that Aryans came into India in 1500 BC and composed their texts in India. So I hope I'll leave that one thought in your minds, and you can look at my talks on YouTube, or you can follow me also on Facebook or on Twitter and get more on this. With that, I'll stop. And Shanti ji, I hope I have not bored your children to death with these things.
No, it was absolutely amazing. It's a wonderful opportunity for them to listen to you. I mean, so much of insight into things which actually we don't know. It's a sad set of affairs that our books don't give the right facts and we get completely deluded with the wrong facts. And that is why the purpose of the subject is for them to do some research and find out for themselves.
Excellent, excellent.
Yes, Raj Vedamji, we are very, very clear about it. We are not wanting to simply glorify. We don't want to say India is the best, India is this, India is this. No, we just want to lay down facts to our youngsters. Let them find it out for themselves. Let them research into themselves whether it is glorifying or whether it is also, how ignorant we have been.
Right.
I think it was amazing, absolutely amazing. Probably you can close the window, we can interact with the children. Children, you can have your questions on, we have your any doubts on that. And I hope you made a note of the YouTube link that Dr. Raj Vedam showed here. Please watch his videos. His videos are absolutely amazing. I think you should spend time watching them so that you will get a lot of clarity onto many things which we really, really have a lot of confusion about. I don't think astronomy can be made simpler than this. It was absolutely amazing,
It's a complex subject, but so much to
For your
learn.
information, Raj Vedamji, I studied astronomy in my postgraduate.
Oh, wonderful,
It was
wonderful, wonderful.
absolutely, completely, different. They never threw any insight into our traditional way of doing, or the whatever you shared here, the so many thousands of years before what has happened in our country is something which was not highlighted at all. Very, very interesting, actually. Children, you have any questions, you can put it. Raj Vedamji, I have just one thing to, I'm actually right now in Dubai, and I'm taking a session for the CBSE principals. So Meena Amma will be here to, Meena Shriram is our administrator in academics in education cell. She'll coordinate with the students. Please ask your questions, children, to sir, so that you will get any questions. Anybody want to ask any questions? Wonderful to have you here, Raj Vedamji. We're privileged.
My pleasure.
Thank you so much. Yeah, anybody wanting to ask any question? Any hands up? Yeah, we have Shreyansh Agarwal from Chinmaya International Residential School. You can ask, unmute and ask Shreyansh.
Thank you, ma'am. Thank you, sir, for addressing us here. We've been very much waiting for this session. We watch your videos constantly and we are very much inspired by what you share. So what I wanted to know is, like, when we speak about our ancestors, what they knew, was it everyone who knew about it, or was it only a few limited people who actually knew these calculations?
Excellent question. Excellent question. So today in India or anywhere in the world, if you ask some person off the road, can you tell me Einstein's theory of relativity? The chances are they will not be able to do it. You might need a PhD in physics in order to do that. So the situation is the same anywhere in the world, any period of time, unless some scholars have devoted attention to learn and read, it will not be easy for them to understand. So in India, we had scholars at different levels. According to the historical works, we know that all over India, there were patashalas. Patashalas are teaching people of all backgrounds, whether they were Brahmanas, Kshatriyas, or Vaishyas, Shudras. Everybody was being taught in the patashalas. What were they learning in patashalas? They were learning grammar, they were learning mathematics, they were learning basic skills, astronomy, basic astronomy, and things of this nature. The monsoon winds are favorable, Roman ships would come to India, and the sailors, rather, the traders would come to India, and they'll trade in cotton cloth. So if you know that in another 6 months' time, monsoon winds will bring them, you know that I want to make so many bales of cotton, you should know how much to invest, right? I have got 5 looms or 10 looms. I can need so many people to, all mathematics. It's all mathematics. So only with mathematics can you succeed. So everybody in India needed mathematics, not just an elite group of people. Evidence is there because India had one of the highest GDP of the world. If you look at works like Angus Madison and others, India had 33% of the world GDP going back 2000 years. And who had that wealth? The wealth was the artisans. So anywhere in the world, even today, if you have an educated workforce, you can make quality products. If you don't have an educated workforce, you cannot make quality products, right? That's a basic fact. If you have mechanics today who can do basic measurements and things like that, you can make good products. But if they don't know to measure, forget it, you can't do it. So to answer your question, there were patashalas that gave elementary education. But then for higher education, you had to go to universities like Nalanda, Takshashila, for which there Very difficult entrance exams. Just like today, you might be thinking, I'll write IIT, JEE, and things like that. Very, very difficult exams, or the CAT exam and things like that. You have to study for days on end to go over there. We have evidence that to join Nalanda, people will come from Japan, Korea, and other places, come to India. They'll stay in India for 2 years learning Sanskrit, because Sanskrit was the language that was used. They'll first learn Sanskrit. They'll learn all the questions that is used. They were cramming schools. Just like you got tutorial schools today to train you for JEE and things like that. There were schools outside Nalanda to train these people to enter Nalanda. Then the professors will grill them and then take the students. So these highly specialized students would spend maybe 7 years, 8 years learning these advanced skills of astronomy, medicine, all these kind of things. Where is the evidence for this? We have that. Shishrita Samhita is telling us what are the qualifications of a medical student? How long does he study? What should he know? How long? What is the period of study? We have all this in Charaka Samhita, Shishrita Samhita. Same thing when you look at astronomy works, we understand all these things. So the knowledge that you're asking about, whether it is astronomical knowledge and other such things, even today, Shreyash and others, if you pick up Siddhanta Shiromani, which is Bhaskara II's work in 1100 current era, you will not understand even one line of it. Because the mathematics is not like today's mathematics. It's written in a different form, plus it's very complex. The way they write polynomials, the way they solve equations, everything is not recognizable because we don't learn those methods. So it's not easy. So ordinary people, even today, if you ask an ordinary person, solve this quadratic equation for me on the road. Well, most people who know high school, that they can solve quadratic equations. But if you've not done high school, you can't solve it, right? Just like that. So depending on the kind of background of that person, they had an education system that will allow them to do this something. The kind of mathematics I talked to you today, elite astronomers like Aryabhatta, like Varahamira, these are the big names we know about, or Lagada, who wrote Vedanga Jyotisha. They're the ones who had this kind of training and they could do this. And they had schools in which they transmitted this knowledge, like the Kerala School of Mathematics and so on. And I'll close your question with one more observation for you to keep in mind. Today, many people are fond of saying Brahmins had the knowledge, they prevented others from getting that knowledge. But I recommend you to Google for a book called Aryabhatiya by William Clark. William Clark was a professor of Sanskrit at Harvard University in 1930s. So he wrote a translation. But I want you to read the preface of that book in which he wrote. He wanted to ask, should Aryabhatta be written with 2 T's in English or 1 T? And he said he had a long argument for that. And one of the arguments says 2 T's means Bhatta. Bhatta references a Brahmin, a person who has got access to all kinds of knowledge and things like that. Whereas if it is 1 T, Bhatta, that means he's like a serving class. That means he's not highest wisdom. Then he said why it should be 1 T only. He has got a list of arguments. What it is telling us is that Aryabhatta was not a Brahmin, but he had access to the highest wisdom of Jyotisha Shastra, such that we are using his calculations even today for the Panchanga, we are using that. So some of the nonsense that we read today, that Brahmins controlled knowledge, is all nonsense. See my talks. In several of my talks, I've discussed this and I demolished these myths. But good question.
Thank you, sir.
Yeah,
Yeah.
the child from CV Kannur, can you introduce yourself and ask your question? We can't hear you. We can't hear you. 1 minute, Shilpa ma'am. I think there are 2 machines. Okay, as we wait, maybe Dr. Shilpa can ask a question. I still can't hear you, Kannur.
Why don't you chat your, rather type
Yeah.
your question in the chat box. I'll read it. Go ahead and type your question. CV Kono, type your question. Okay, when you're typing a question, let's go to the next person and I'll address your question, but go ahead and type it. So we have the next one.
Suvarna ji, can you ask a question?
Yeah, sure, ma'am. I'm waiting. Raj Vedam sir, humble pranams to you. It's the most awaited session. We and the students, we follow you very regularly. Sir, you have shown a map telling that most of the northern territories, they used to follow the solar calendar. That's why.
No, not north, south. South follows the solar. North is Purnimanta.
Purnimanta. Then, sir, Rama is from Sun Dynasty. So, and then Pandavas are from Chandravamsha.
Yes.
So, I'm not able to relate that, sir.
So we have to understand, we have to try to understand from the lineages of their, where they came from, originated, and why they used two different things. We know if you take a look at, the Purana chronology, we know that Vaivasvata Manu, who was he? He was a Dravida Desha king. He came
Fantastic,
from
sir. First time I am getting to know this. Okay.
Yes. If you read the Matsya Purana, if you look at the Matsya Purana, it talks about Vaivasvata Manu came from Dravida Desha. So from southern India, he went to where Prayaga is, and the whole dynasty of Ailas started over there. So from him came the Ailas through, I think, his daughter Ila, who was in the Lunar dynasty, and on the other side, I forget the name, Ikshvaku from the solar dynasty. So that is where these things followed. So our interpretation today is that it is the people who followed different calendar method for maintaining time. And from their lineages came all the other lineages, whether you see the Pandavas, Yadavas, everybody have come from these lineages. So you can try and follow through where they came, where they settled geographically, and so on. One interesting book to read is Parjita. Look for Parjita, Pargiter, F.E. Parjita. I think it is called, I have a book on my shelf, but I can't find it now. But Parjita on chronology of India, I think ancient India or something like that, traditions of ancient India. So there is given even the geographical locations of the various chronologies mentioned in the Puranas. And you can see how it is spread over the central part of India, eastern part, some in the northern part, some in the southern part, and so on. So it lends credence to what I'm saying here, that different parts of India could have used different calendars.
Yes, sir. I got very much of the clarity because Vaivasvata Manu is from Dravida, and then it's quite understood.
Yes. Okay.
Thank you, sir. I have another question. Shall I?
Sure.
Sir, generally we see Muhurtam auspicious time to do the things. So in most of our families, we say that if you are in an urgency, if you are not able to find any good time to do the things, do it in Abhijit Lagna, where it's 12 noon exactly. So what is the scientific significance for that, sir?
I am not an expert in this, but I'll give you some idea, but you may have to reference to some other expert for this. So in India, we always have followed the Vaisheshika. The Vaisheshikas is a pramana where we have perception and inference, right? Perception inference is through pratyaksha anumana. That's what we followed. So in other words, it was a causal relationship. It was not a supernatural relationship, but causal relationship. Indians looked for where is the prime mover, what is the cause of something happening, and so on. So in India, even the movements of these bodies, heavenly bodies, they wanted to answer, why is it moving? Why is the planet moving? So they, in very ancient times, they said, gave different devatas in different places. So some planets are moving towards the devata by his power. It's coming towards him and he's pushing it away. The same ideas are encoded, that there is a prime mover, there's a cause and an effect kind of relationship happening here that is encoded over here. So these ideas eventually got encoded into auspiciousness of a particular devata when a certain nakshatra, or rather certain planet is coming into this house and things of this nature, including this notion of time. When is a auspicious time for a muhurta? All these things were with reference to these kind of notions. So one reference for these things is Varahamira's book, Brihad Jataka. you may want to read. That's a very voluminous work, but if you have the patience to read that, you may get more ideas over there. But that is the beginning source for many of these other works.
Thank you, sir.
Okay, I am now looking at the chat window. So the question is, Rig Veda says this number 3339, Devas worship Agni. Can you explain this number concept? I cannot explain it without looking at the slide because the details are so complicated. So I have referenced a book over there. The book is by Professor Subhash Kak, Astronomical Code of the Rig Veda. So over there, I also reference B.G. Siddharth. He's a researcher, and the paper is over there. And what they're doing is they're trying to look for synchronism between the sun and the moon. Okay, they know that the sun is taking about 365.24 days, but they mapped it into 12 months of 30 days each, 360 days. That's what Rigveda is saying, 360 spokes and so on. Similarly, lunar month. If you follow the synodic month, it's 29.5 days. They rounded it to approximately 30. They know that there is a difference. So they know there's a discrepancy between the solar year and the lunar year. Then they try to find out how many lunar months should elapse before there is synchrony again with Adhika Masa and so on. All those figures are encoded inside 3339. So in various factorizations, these things are encoded over there. I cannot coherently tell you without referring to the notes because it's too complicated even for me. But please do read that book. And if you stop the video, when you play back the video, you'll see the paper I referenced, B.G. Siddharth. So reference that paper. You can get it on Google, and that explains to you those various entities. Okay, there's one more question in the chat window from CV. Is it
Pallavur.
Pallavur?
Yeah.
Okay.
Want me
Drishya,
to do it?
modern astronomy has several branches like astrophysics, astrochemistry, astrobiology, and everything. Question is, did these branches also develop parallel to general astronomy? It was developed. Is there any archaeological evidence for that? So today we can use astronomy for various things, but let us back up a little bit. How was astronomy used in India? Astronomy was used by everybody for the calendar, starting from people who somebody asked about auspicious time. When is an auspicious time for a certain entity? When does a festival come? Festivals by solar calendar is easy. By lunar calendars, festivals are not that easy to predict. You must know Adhika Masa and other things. It'll fall 1 month or so on, this side, that side. You should know that. There is another application. Yet another application was things like farmers, when to do the harvesting, when to do the planting. That was also done by nakshatra model. So they were using the nakshatra model to understand when rainy season would start, when they should do things. So a lot of life activity in India followed the celestial calendar because of the rhythm of life, the Rita, right? So they were trying to say, as in the cosmos, so also here on earth. So everything in India, everything was tied to the celestial cycles. Whatever artisan that was, they were doing that. So that is one aspect of looking at your question. Another aspect is these branches, astrophysics, astrochemistry. Let's start with astrophysics first. So these are modern branches, right? These are modern branches that is trying to understand the physics governing the phenomena we see in outer space. Whether it is, let us start with simple things like comets, how are they working? Or things like galaxies, how do they form? Or the blue shift and red shift that we see, what is happening over there? These phenomena, to understand causal relationships, astrophysicists try to propose models for that, mathematics to explain the observed phenomena and things like that. Then things like astrobiology, I'm going to interpret it. I believe you're meaning the search for extraterrestrial life and things of this nature. For example, today from the Earth, we can observe the atmosphere of Venus by looking at the spectroscopy of results from there. And people have seen things like phosphine gas. Phosphine is known on the Earth to be released by living organisms, but that is present in the upper atmosphere of Venus, giving reason for us to believe that maybe life exists in the clouds of Venus, cellular life at least. So those kinds of things. And things like radio astronomy is today only when we understand the electromagnetic spectrum, how big it is, various frequencies, the phenomena over there, only then we can make a call on different instruments to measure these various things. That is certainly not in the past. So modern astronomy has evolved after our understanding of many of these phenomena. And I want to tell you that this is a growing field. Even in 1930, people had no idea what a galaxy was. They did not know what a galaxy is. They thought everything we see in the sky, the Milky Way, is the entire universe. They thought there is nothing else. Through the telescopes, they could see Andromeda, but they did not know Andromeda is a separate galaxy. They thought it's a ball of gas in our universe. It was only after Hubble, the scientist called Hubble, he recognized certain Cepheid variables and things. I'm not going into the details there, but he was able to realize that that is not in our Milky Way, but very, very far away. Only then, 1930 onwards, people speculated that there were galaxies and much bigger. So the point is that sciences are not as if the West has all these science Renaissance period and rest of the world doesn't have it. It's growing even today. So some of these branches, like you have astrochemistry, geology, biology, and others, these are growing today. These are not some things that are old, based on our thinking that we can use various things to talk about various things. So is there evidence of archaeological evidence for that? Well, I don't know what kind of evidence you're looking for, but geology, if you look at the rocks, you can look at the magnetism in rocks and you can figure out certain things. And if you look at ice core samples from Greenland, Antarctica, and places like that, we can look at the isotopes in those things and figure out what were the solar activity like at various points in time. I'd suggest you read an article of mine called Once Upon a Time, 9,000 Years Ago. Once again, the title is Once Upon a Time, 9,000 Years Ago on medium.com. There, I try to show that the story of Surya, Sanjana, and Ashwins, that is 9,000 years old. Now, I'm not talking nonsense. I've given some evidence for that based on published papers, why that story should be pegged to 9,000 years ago, and that uses a certain astrogeology to do that. I hope that addresses that to your question.
There's another question on the chat box from Chinma Vidyalaya Nagapatnam. Shall I read it, sir?
Yes, please go ahead.
Yeah, so there are numerous unknown galaxies in the universe. Is it possible to identify the measurements and information about the planets in other galaxies by using Indian astronomy?
Good question. So there is no such thing as Indian astronomy and Western astronomy, because it is Indian astronomy that seeded Western astronomy. Everything in the West, if you read my works or see my talks, you'll understand that how Indian knowledge system seeded the West through the Arabs, and that's how they learned. So there's no separate thing like Western astronomy. Now the question is, how do we identify measurements, information about planets and other galaxies? So today we do that by two mechanisms, right? One of them is called the transit method. If there is a planet that is going around a star in a different galaxy, not our galaxy, but a different galaxy, we can make light measurements, how the luminosity and other things, the light got from there. And if the light dips down, through that dip, we can make figure out what is the estimate, rather, that there is a planet of this size, this mass, and so on. And depending on its periodicity, we can even say what is its orbital period around its planet. Those are the methods that we use. And the methods are primarily, one, you must have a detector, photo detector. You must have telescopes. So these are not, you cannot say these are Western things, because these are global entities. It's a connected chain of knowledge from India to the West over here. So yeah, the mathematics use is very trivial in a sense, and the mathematics tradition also goes to India. So the question is a little strange to pose, but using the mathematics that has evolved in India and using the scientific knowledge we have today, which is a collective of the entire world, Indian scientists are there everywhere, as well as Western scientists and others. So the collective knowledge that we have, we are able to do these amazing things.
Yeah, Raman Bharadwaj, would you want to ask a question? Raman Bharadwaj, Vidya Bharati.
Yes, Hari Om sir. Sir, I am
Hari Om.
Raman Bharadwaj from Vidyabhati Senior Vidyalaya, Jamshedpur. Sir, my question is that in Indian astronomy we have repeated references to Shani. That in Hindi we say uska Shani bhari hai. So, is there any special means reference to Shani in astronomy that we hear it so commonly, which we means the level of importance which is given to Shani is not given to other grahas. So, is there any special reference to that?
Well, like I said, Indians have identified Shani as a planet for quite some time. Orbital period of Shani has been known, like I showed you Parashara Tantra, 1400 BC, that is approximately 3,500 years ago. He's already saying in how much, 28 years it takes to go around the 27 nakshatras. So there's already knowledge about all of these things over in India itself. Question comes, where did the association of Shani with some importance come? It has come in Brihat Jataka, Varahamihira, his works, and perhaps even earlier. So those are based on ideas that Indians had about, like I told you, about Vaisheshika Sutra, about understanding causal relationships, that movements of certain things happen because of malicious entities or because of benevolent entities. And the planet comes over here, there's a retrograde and other such things. Their understanding was there's a cause and effect relationship by either something that is good or something that is bad. So these identifications and associations came about. I cannot tell you how or why, but it came in Varahamihira's works. And since then, they have become popular, more and more popular these days. So difficult to say, are these really true? Are these really relevant? I cannot give a good answer. I'll tell you why. We know that in our Indian Jyotish, we talk about 7-year cycles of Shani. Are you familiar with that? That most people go through 3 periods of 7-year cycles, and it leaves people in certain stress and other such. This is the association. Now, is that just nonsense, or is that some causal phenomena? That is a question to ask. So in my research, I have tried to see about whether there is a correlation between the cycles, the various cycles seen on Earth. For example, we have a day and night cycle, right? We have a day and night cycle. We got various other cycles, biological cycles, a circadian rhythm cycle. We have got season cycle. We got a yearly cycle and things like that. Indians observed cycles everywhere. So is it possible that they observed certain things? Let me give you an idea. Supposing a child is born during a time of intense drought, summertime, intense drought. And it is not a modern life, but go back 2000 years where people are subsistence literally. The survival of the child is in question, right? Because the mother doesn't have enough food to eat. She can't feed her child. It could be sickly, it grows sick and so on. Similarly, if a child is born in the monsoon time, India in the monsoon time, waterborne diseases, you got malaria, cholera, dysentery. It has been there for thousands and thousands of years. We've had this. So maybe it's subject to something else. So people have observed cycles, that certain cycles are there. So the question is, can we peg those cycles to people at a certain point in time? And our rishis have been great at doing that. They've been taking the birth chart of people and trying to predict what the cycles will be. So if we understand that all human activity falls not within infinite expressions, but within limited expressions. I know it's very complex to understand, but let me give a different example. Supposing you go today and buy something online on Amazon. The minute you buy something, it'll say, you can also try this one, or you can also try this one. Sometimes it is a pretty good suggestion, sometimes it's nonsense. But the point is, how are they making that suggestion? Because several other people have done that. They're able to do something called collaborative filtering. It's a mathematical algorithm, which says if you have a matrix, let us say there are some entries filled in the matrix, but some entries are not filled. Can I estimate what that unfilled matrix entry will be based on the known other quantities? There are algorithms today that can help you to do that. So this is possible because there's a mathematical law that says a law of large numbers. All distributions tend towards the normal, the Gaussian distribution, if it is a sufficiently large sample that you have. What does that mean? If it is normal, You got a mean, you got a variance, and other such things, right? So this is what our empirical observations of the universe is telling us, that everything, every phenomena, if you collect it sufficiently large, it falls within predictable patterns. That means there's a finite number of relationships expressible over here. That same idea expresses a human life. We think that each of our lives is unique and it's so different from others, but we all do the same things. We wake up in the morning, we dress up, we go to work, we catch a bus, go to work, and we eat lunch, we come back home, we watch TV, we go to sleep. So if you look at the activities we do, that also falls within limited expressions, limited patterns. Our rishis understood this. They tried to peg it to the celestial calendar, and they tried to say at different periods of time, you'll have good periods, bad periods, good periods. And I have found some surprising correlations with the 7-year cycle. In many instances that I've studied, I found that. I cannot explain it as a scientist other than to call out these correlations. So it has nothing to do with some benevolent planet or some less. It's a pegging of phenomena on Earth to a celestial cycle. It's a long answer to your question, but I hope it makes sense.
Thank you.
Yes, sir. So I had another question that relating to the Adhik Masa. This year we had an Adhik Masa that the month of Shravan was repeated. So was it merely a random selection that Shravan was selected to be repeated, or is it a rule that this particular Masa is going to be repeated this year?
Or is my internet stable?
Yeah, now it's better.
Okay. So there are well-defined formulas on when the Adhika Masa should be inserted. For example, based on the Tithi model, based on the Shankranti model, when in 30 days' time the sun enters from one to the other, how many lunations do we expect there? That if certain things don't gel correctly, that is when they know an additional month is. Can you hear me?
Yes.
I don't know what happened.
We lost you. Yeah.
It restarted.
Yeah. So you might have to repeat what you said in between. Seem to be frozen again, Doctor.
Yeah, Hari Om everyone. I'm Srinivas from Vidyabharati Chennai Vidyalaya. I'm thankful to CCMT, Murthy Madam, Amma, and Meena Amma, and the renowned speaker for today, Raj Vedam sir, because even I am taking astronomy along with mathematics, but I don't think that any other better way to teach this topic than what sir has explained us. Even the facts that he has given, how to calculate the lunar month and the solar month, and how these things are correlating, and what is the contribution of our Indians towards this astronomy. And sir has rightly said that it is not concerned to the Eastern or the Western, but it is what India has encouraged, and I think this has given us all the encouragement to do a lot of studies into this topic, and the students will benefit a lot in future course of action. I'm very, very thankful to the sir for giving his precious time and sharing with us so much of information. And even I was with the diary to note all the informations, but I could not note all many information. But then I want that these videos, if you can share with us, it will be very useful to us. Thank you.
Thank you, Srinivas ji. I think Dr. Raj Vedam ji has lost his connection. There he is.
Apologies. Looks like my internet is playing tricks on me. Maybe the DNS server is moving over at midnight. But anyway.
Raj Vedam ji, thank you very much.
It's been my pleasure.
Excellent session.
Thank you. Thank you. I hope your students got sufficiently out of it. It's not too complex for them. I hope it is not too complex.
I hope it was complex enough for their curiosity to be risen, because what I heard some students sometimes say, oh, we want to take mathematics, we don't want to take KTPI because we are going in for science. They'll soon realize that the KTPI people know more science than them who take mathematics. So
Okay. So I guess if they're interested, they can pause the video because it's recorded. They can pause the video at various points. I've given the references on every slide, what I've used. So they can try to recover those references and they can read it. Hopefully that will spur their own interest.
Yeah, we will be putting this up, the recorded version at the KTPI website. So children can always go back and, like Dr. Raj Vedam said, re-listen to the whole thing.
Okay.
Somebody from Chinmay Vidyalaya, Kasaragod, you wanted to say something?
I see there's a question
And
from Pranav Pandey.
We can't hear you, Sunil ji. No, we still can't hear you.
You're muted.
I think there's a lot
You
of
can type your question. You can type your question. I can read the question. Please type in the chat box. I see there is one question in the chat box from Pranav Pandey. What is a nakshatra? A constellation or a single star? So it depends. It depends. Some of them are a collection of stars. Some of them are a single star. For example, Jeshta is a single star over there. Aldebaran, which is Rohini, there's a single star out there. But Punarvashu, like I showed today, it is Diti and Aditi, Castor Pollux, is the 2 stars. Kritika is a Pleiades, which is about 6 or 7 stars over there. So it depends. Some of them are a collection of stars. Some of them are a single star.